In this section, we will be talking about how to add, subtract, multiply, and divide functions. Whenever you want to add functions, well, pretty much add, subtract, multiply, or divide functions, you really just need to add the two functions together or subtract the two functions. Remember, whenever you're subtracting, to put the second one in parentheses at least. Normally you would want to put them both in parentheses, but you want to do that because you have to distribute this negative. When you multiply functions, you literally just multiply them together. When you divide them, of course, you put the first one on top and the second one on bottom. You have to make sure that the denominator is not 0. Anything else is okay, just don't let the denominator be 0. That's what this is all about right here. The domains of each of the new functions consist of the common elements of the domains of f and g individually. So you find what the domains of the two functions have in common, and that's what the domain of the combined function will be. So let's have a look at this first example. Given that f of 6 equals 10 and g of 6 equals 9, find f minus g of 6 and f divided by g of 6. So f minus g of 6. That means f of 6 minus g of 6. Well, f of 6 is negative 10, and g of 6 is 9. And then negative 10 minus 9 is negative 19. So f minus g of 6 is equal to negative 19. Okay, if you have f divided by g of 6, that means f of 6 divided by g of 6. Well, f of 6 is negative 10, and g of 6 is 9. So f divided by g of 6 is equal to negative 10 ninths. Given the two functions, f of x equals 1 divided by x, and g of x equals the greatest integer function x plus 3, find f plus g of x and f times g of x. So in that first one, we want to find f plus g of x. That just means find f of x plus g of x. Well, f of x is 1 over x, and g of x is this greatest integer function. So this is the sum, f plus g of x. Okay, how about f times g of x? That will be f of x times g of x. Don't really need that, do I? Okay, so we're going to have f of x, which is 1 over x, times g of x, which is this greatest integer function. So if you multiply those, you would end up with this over x. Here you have to make sure that x is not equal to 0. Here is the same thing. X cannot be 0. And you know that because 0 is not in the domain of f to begin with. So it cannot be in the combination, the addition or the multiplication of f and g. Based on the graphs of f and g, determine the domain of f divided by g and evaluate f divided by g of negative 1. Okay, so remember that we need to look at what the functions f and g have in common, what their domains have in common. So the domain of f is pretty much everything. The domain of g is also everything. So if we have f divided by g, we just need to make sure that the output of g is not 0. So at what values of x do you get an output or a y value of 0? Well, that would be on this line right here. If x is 0, for the f function, y is also 0. Is that okay? Can you have 0 in the numerator? Sure. Where you can't have 0 is in the denominator. So here and here would be where your y values come out to be 0. So for what x values do you get y equals 0? We get that at -2 and at 2. So the domain is everything except those two values. So you would say it's -infinity to -2, not including -2. It goes from -2 to 2, not including either of those endpoints. And it goes from 2 to infinity, not including the 2. So this will be the domain of f divided by g. So now we have to figure out what is f divided by g of -1. Well, there's a couple of ways you can do this, but that's the same thing as f of -1 divided by g of -1. Well, f of -1, here's -1. When you put that in f, that's the red one, f of -1 is 1. Well, what is g of -1? If you put -1 into g, you get 3. So this turns out to be 1/3.